it's kind of a mouthful, high quality geophysical coverage of prospective ground in BC. What I'd like to do is step back a bit and maybe take a bit of a generalist view, because there's a lot of very good data that's being acquired by Geoscience BC, and some of it's done in very high quality, well, it's all done to high quality, but in tremendous detail. So one of the problems is if you drill down into a small space, you need to go backwards and then look at the world from a larger viewpoint in order to use that information. And regional aeromagnetics is actually a large view of the world. I just went into the Geoscience website and I counted the data releases. So this is not all the projects, there's many more projects, but these are the ones where you can download quite large data sets of different types. And there's 49 geochemistry data releases, there's 21 geophysical data releases, there's 14 geology and mineral deposit data releases, and 10 oil and gas data releases. And if you look at the geophysical data releases, there was 4 quite large MAG and EM data ones that would include the Quest projects. There's 6 magnetic data acquisition, there's 4 gravity data acquisition, and there's 7 interpretation and rock properties. And then there's additional case studies and smaller studies. But if you take the magnetic data acquisition, starting in 2012, you've got the Quest Northwest Block 1, Block 2, the North Vancouver Island, the Quest Northwest Block 3, the TREC project, and the Blackwater purchase data project. And I think it's kind of interesting that since 2012, Geoscience BC has concentrated on collecting high-resolution regional aeromagnetics. So it's 250 line kilometer spacing, and it's using fixed-wing helicopters. Fixed-wing is cheaper, but if you're in the mountains, you can't use fixed-wing, you need to use helicopter, and that's one of the reasons that the Geological Survey of Canada data in some areas of high interest is not very good, because they flew higher altitude, wider space lines, and it was fixed-wing data. When it comes down to covering large areas with helicopter surveys, that's been something that Geoscience BC has started to do in British Columbia. So areas selected for survey are areas with good mineral potential and poor existing aeromagnetic data. And the area selection has been driven by industry through the vehicle of the Technical Advisory Committee. And this is really, I think, important, that the TAC came to the conclusion that they wanted 250 meter line spacing data, they wanted high quality data, and so the surveys were specified with that in mind. And it's very important also to realize that there's complementary geochemical and geological mapping surveys. These have been generously funded as well, and none of these surveys exist by themselves. They all help each other. So when you're looking at the data, you want to look at all of it to come to the best areas to look for new mines. I've just got a map up here of the TREC data, which was released last year, and it's 104,000 kilometers of fixed-wing data. The country was a little bit steeper than what we had in the Quest area, but it was we were able to fly it with a fixed-wing stall aircraft with a very good magnetic system on it, and also we were able to purchase quite large amounts of data that had already been flown by companies over their own prospects, and merge that data into the public data set. And what's going on now is a large helicopter magnetic survey in the search area. So if you look at this, now if I tap this, can I just move the mouse around? I have to find the mouse. Oh, there we are. Okay, so you should be able to see the mouse. Kitimat is here. Terrace is here. Smithers is over here. It's a big area. It's very rough, mountainous. It's being flown with a close drape, and it's about 30,000 line kilometers. So the survey is about 3/4 done. At the moment it's raining in Kitimat, so aircraft are on the ground. But we're hoping that we'll be able to finish it this year, and that data will be released into the public domain as soon as we are able to process it. This is after Craig Hart at UBC, and I think it's a very useful way to organize your thoughts when you're considering your search for a mineral deposit. So you want to, instead of looking at the detail, you want to step back and look at the system, the mineral system, and how the deposit has been emplaced. So the parts of the system are that you need to have a host lithology. You generally need a structure that can generate dilation and which the ore fluids can come in, and you need some kind of gradient so that the mineralization can be deposited in the host lithology. And then around that deposit, you'll have a small deposit. It can be a big deposit, but much larger than it is the visible alteration, and then much larger around that is the invisible alteration with a thermal alteration halo around it. So if you think of these as being the elements of a deposit, then you want to think of them in specific terms, how your particular case is going to fit into that model. And one of the, I think, really important things is that lithology will interact with structure, and that will produce the dilation that is necessary for a deposit to form in the host lithology. And if you think about the alteration footprints, you have the ore at the intersection of the structure and where the dilation is in the host, but you have visible alteration surrounding that and invisible alteration, and those have a geochemical signature. So when you're looking for a deposit, you want to have the smell of metal, and then to look for these controls which will locate the deposit. So I put this same model into a Venn diagram, and I say, well, if you're going to look for something, you would start off with probably in the appropriate host, and so you would use the geology map, and you might refine it into subunits if the magnetic map allows you to do it, because the magnetics show you the response of the rocks under cover, and that allows the geology to be extended away from the outcrop where it was mapped. But there will be differentiation in the geology that's different from the differentiation in the magnetics. That the magnetics are responding to the magnetic susceptibility of the rocks, and that correlates with the geology, but is not actually a geological map. You want to look for a seal or gradient that might precipitate or cause the deposition of the mineralization from the ore fluids. So you would use the geological mapping, the magnetic gradients from the magnetic map, and you'd cross-check the geological and the magnetic maps. And some of the later speakers, James Sidorn, I'm sure, is going to talk about using the magnetics to follow contacts and structure. For the fluid pathway, you would look for structure that mapped faults, linear features in the magnetic map, features that cross-cut or parallel geology, kinks, offsets, or the intersection of contacts may indicate dilation zones. And for fluid flow, you're looking for a direct indication of fluid flow. That's generally a geochemical anomaly and mapped alteration. And also you can see indirect indications that you might have non-conforming magnetic anomalies. Lows or highs that indicate placement or removal of magnetic minerals, and which are intersecting the geology that's being mapped. So when you're looking for the ore, you go to the intersection of these features, and you're usually following the structure. In the big picture, it's good to be on a regional gravity gradient. And this is just the gravity at Timmins Porcupine in Ontario, and the blue areas are the gravity lows, the red areas are the gravity highs. This dotted line marks the gradient from high to low. There's the McIntyre mine, 10 million ounces plus. The Dome, 15 million plus. Hollinger, 19 million plus. And all the other deposits which follow around on this gravity gradient. This is kind of it's a dramatic example, but it's generally true statistically that the best place to find big deposits is on regional gravity gradients, and that's probably because they're responding to deep features in the Earth's crust, either big structures or they're over the edges of intrusives. This is a magnetic map over the Wallaby gold deposit in West Australia. And there's two anomalies here that are worth noting. This map was around for a long time. And this magnetic anomaly is actually the ore body. There's a magnetite halo directly around the gold mineralization. It's structurally controlled. But the other feature which is of interest is the large halo in the magnetics, which you can see out in here, which is actually the pyrrhotite alteration surrounding the deposit. And when you look at it on this map, it's obvious. But the thing about obvious is that people usually don't see the obvious thing until after the fact. So you really do need to stand back and think about the model, think about what you're looking for, evidence of fluid flow, and where something might be standing out and giving you a hint. Here's the Mount Pleasant gold deposit, and the thing I want to point out, get this mouse, there it is. Okay, here's the deposit. So look at the geology here. You see the geology trends along this way? Okay, so the unit that the deposit is contained within comes around here. It's controlled by structure, but if you look at the magnetics, the interesting thing is that this magnetic feature here is cross-cutting the geological map. So the highs close to the deposit are actually magnetite, and the larger halo is actually the pyrrhotite halo that surrounds the deposit. So when you look at that without looking at the geology, it's not an anomaly. Okay, there's lots of mag anomalies on this map. But when you look at the geology and you realize that this low magnetic high, which crosses the geological units, is actually contained within these two blocks, then the suggestion is that that's a magnetic alteration feature. It's a result of the fluids coming in. And so if you had some geochemical anomaly there, hint that there was an anomaly in the metals of interest, then that would be a very, very positive indication because it's a large area and indicates large fluids flow. Okay, this is just a map from the aeromagnetics on the Trek deposit. It's fairly small scale. You can see that 25 kilometers is covered fairly quickly, and I've put the min-file deposits on here. But the important thing of this is that if you look at the setting of these deposits, you'll see that they all sit on the edges of magnetic anomalies. Okay, there's a couple of styles here, but here's the Blackwater West is plotted here. Okay, the Buzz is plotted here. Key West is plotted here. You come up to these ones up here. There's Chew, April, Ben. They're all around these features, which are probably intrusives. Now, how do I go back here? No. Okay. And so the first thing you would do there is if you wanted to go and look for areas of interest, it's pretty clear you want to be on the edges of those anomalies. But the other thing is that there's a number of similar looking anomalies which are nearby, and so it'll be well worthwhile looking at the geochemistry and looking at the geology to see if those are of interest. And here's one. I mean, it's obvious. Here's another one here. But it's not unless you look at it like that that you understand what you might be seeing. Okay, here's a molybdenum deposit, molybdenum prospect in the Minfile deposit and the Trek deposit as well. It's here. It's inside a feature that's probably about 15 or 20K across. There's a 10K feature in here, very, very smooth magnetics. My guess is that this is an alteration system and that you have an intrusive system with molybdenum mineralization. Finding the moly in, a mine at that scale, you could put 3 or 4 of them into that feature. So it's not a simple problem to just look at this map and find the mine. But this will draw your attention and take you to this region of interest. Okay, something that's happened, which I think is fantastic, is that the PCGS has produced this map server, which will serve you maps and make you plots at fixed scales. So here's just the BC geology. Here's the geochemical sampling. Here's gravity. Here's the aeromag. So I'm going to dive in here and just show you an example from northern Vancouver Island. So here's the island copper pit, and this is taken on the Geoscience BC map server. One of the things about looking at a Landsat image is you can actually check that the features that you think are there are really there, because often the coordinates are wrong or something. So there's where the island pit is, island copper pit. Okay, now I've put on the geology and I have made it a little bit transparent so that you can see underneath, and you can see that the island copper pit sits in the Bonanza volcanic suite, and there is just to the west of it the island plutonic suite is mapped, and there's a number of examples of the island plutonic suite mapped out here. So when you look at the magnetics, one of the things that comes out of this is that you can see the magnetic aureole around the plutonic suite. So the first thing here is that it's pretty clear in this region in here that probably the mapping is wrong, and maybe up in here this contact isn't quite right. It's interesting that this feature is here and the pit is here. So I would redraw the limits of the intrusives, the plutonic suite, like that. And then you wonder what's happening at the mine location. So the interesting thing is exactly at the mine, there's an anomaly which on each side of it, which looks like the alteration aureole. But at the mine, there's a hole in that. And I think what's happened is that the mine has mined through the magnetic aureole over the top of it, and that there is an intrusive suite, an intrusion below it, which is probably indicated by this magnetic low. And, well, you can see the low immediately north of the mine location with the alteration features from the contact aureole of the intrusive and the hole in that, exactly where the mine sits. So if you go in and you say, where are there similar features? And just looking at this on the screen, you come up with 4 features in a line, which is a good thing. That's encouraging, which are potentially similar environments and possible targets. And so I brought up the ARIS reports in the map server, and this report 21581 is the Marissa claims, and it's actually had IP done on it, and it's been drilled, and they did hit mineralization. They hit economic grades of copper mineralization. So that's kind of a rush through it, but I think this is incredibly powerful, and the important thing is the ability to combine the different data sets in the overview and to step back and take a systems approach so that you're using the information you can gather from each of the data sets. So thank you.